All right, let's take a look at this problem um, where we're given values for y1, y2, and y3. And then we are told to find all values of x for which these given values of y1, 2, and 3 are such that the sum of 8 times y1 and 8 times y2, so the sum of means we're adding, is the product of 8 and y3. So is we replace with equals, product means that we're multiplying. The product of 8 and y3 means multiply 8 times y3. So in this particular equation, before we replace y1, y2, and y3 with their given expressions, we can divide 8 out of this problem. Since every term contains a factor of 8, we can actually divide that factor right out the problem. And when we can do that, it always makes our work easier. So 8y1 divided by 8 is simply y1. 8y2 divided by 8 is simply y2. And 8y3 divided by 8 is simply y3. So we're really just going to go in and replace y1 with 1 over x. So wherever we see a y1, we're going to put 1 over x. y2 with 1 over 4x. And y3 with 1 over x minus 4. Now what we need to do for this problem is we actually need to solve it. But this is what we call a rational equation. And there are some particular concerns that we have when we solve this type of equation. One of the concerns that we have is the fact that we never want our denominator, since our denominators contain variables, we want to make sure that we realize any value of x that makes any of these denominators 0 has to be restricted. So I'm going to take each of these denominators and I'm going to state that they can't be 0. So x can't be 0, 4x may not be 0, and x minus 4 can't be 0. So this expression, this inequality is already simplified. These other two, we're going to have to isolate x. So here we're going to divide, so we can treat an unequal sign. It has properties exactly identical to an equation, in that I can divide both sides of the equation by any non-zero number. So x not equal to 0 and 4x not equal to 0 actually wind up giving us the same restriction. And that restriction is x can't equal 0. All right, now another property of equality that's also a property of an unequal or an inequality of this type is that I can add the same number to both sides of the equation. So I'm going to isolate x on this side, or in this expression, x minus 4 not equal to 0, by adding 4 to both sides. So I wind up with the fact that x cannot equal to 4. And both the first denominator and the second denominator actually give us the same single restriction, and that is that x cannot equal to 0. So these are my restricted values. A lot of times we just say restrictions. If one of these should wind up being what is a possible solution, we would have to actually discard it. Wait a minute, I'm having a little problem with my pen here. Let me try to fix this. Okay. And I think I'll just type this in. Okay, so these are our restricted values. X can't equal 0 and x cannot equal to 4. And I just have to keep those in mind. All right, now the next thing that I need to do is find the least common denominator. So what I'm going to do is I'm going to begin by writing a product that contains any factor that appears in any denominator, and that factor will have to be raised to the highest power to which it ever appeared. So I notice that I'm going to look at the first denominator, which merely has a factor of x in it. Now the second denominator has two factors in it. It has a factor of 4 and a factor of x. Now x has already appeared as a factor, so I don't need to write that again. But the 4 has not yet appeared as a factor. So 4 does need to be written as a factor in the LCD. And factors are numbers, variables, or expressions that are multiplied. So a factor is something that is multiplied. Now when I get to the third denominator, that contains the single factor x minus 4. That factor consists of two terms, but itself is a single factor. So in order to link those two terms together and indicate that they represent a single factor, I put a parenthesis around them. So notice my least common denominator. This is the expression that each denominator will divide into evenly. The least common denominator is 4 times x times the quantity x minus 4. Now what we're going to do is we are going to clear the fractions. So we're going to clear the fractions in the equation by multiplying each term by the least common denominator. So that's actually what we're getting ready to do now. All right, so every term of this original equation is going to get multiplied by 4 times x minus 4. So that's what we're getting ready to do now. So I'm going to kind of spread this out a little bit. And remember, the whole point of this multiplying that we're doing, the whole point is for us to clear the equation of fractions. So we're going to multiply every term by 4x times x minus 4. And what I'm going to do, since I have 3 terms, I'm going to be multiplying by that each of those 3 terms by that LCD. So I'm going to multiply the first term by that LCD. I'm going to multiply the second term by that LCD. And I'm also going to multiply the third term by that LCD. All right, now remember, the whole point in this product that I'm doing, that I'm completing, the whole point is to clear the equation of fractions. So this process allows me to clear the equation of fractions. So what I want to do is I want to actually divide each denominator into that LCD. So when I divide x into this LCD, 4x times x minus 4, the x's divide out. And notice I don't use the word cancel. Let me do that again. I want to try to work a little more neatly here. I use the word divide because that reminds me that that's actually what I'm doing. I'm actually dividing. I'm dividing, so x divides into x once. And anything multiplies, so there's really a 1 here. 4 times 1 times x minus 4 is simply 4 times x minus 4. And there's also a 1 here in the denominator. But whenever 1 is a denominator, I can leave that denominator unwritten. So here I'm going to divide this 4x into this 4x. Remember, my whole point is to choose an expression that each denominator divides into evenly. So when I multiply each term by the common denominator, in this case I've actually used the least common denominator, I want to actually divide that denominator into the common factor that matches that denominator factor that's part of the least common denominator. And my goal is to divide and rid the expression of fractions. So notice that the 4x in the denominator divides evenly, leaving a 1 in the numerator and a 1 in the denominator. So 4x divided into 4x is 1. And 4x divided into 4x is 1. So I'm left with 1 times x minus 4 times 1 in the numerator. So that's an x minus 4. Whenever I have a denominator of 1, I can always leave that unwritten. Here, my denominator of x minus 4 divides into itself once, and x minus 4 divided into x minus 4 gives me a 1 in the numerator. So you can look at it as you're dividing the numerator and the denominator by x minus 4. You can look at it that way. Or you can look at it as you're dividing this denominator of x minus 4 into this denominator of x minus 4, into this factor of x minus 4. Both ideas are correct and give the same result. So I really have left 4x times 1 times 1, which is 4x. So let's multiply, and we get 4. Let's use the distributive property. 4 times x is 4x. 4 times minus 4 is negative 16. Plus x minus 4 equals to 4x. 4x plus x is 5x. So we're going to combine like terms. Minus 16 minus 4 is minus 20. And let's subtract 5x from both sides so that we have all of our x's combined into a single term on one side of the equals, and anything that doesn't have an x combined into a single term on the other side of the equals. So negative 20 equals negative x. And now let's divide both sides of this equation by negative 1 so that we have merely an x on one side of the equation. So negative 20 divided by negative 1 is 20, or you could look at it as you're multiplying by negative 1. Negative 1x, negative x is the same as negative 1x, divided by negative 1 is simply x. So my solution set is the set that contains the number 20. And I could actually go back and check this, and it would make the left side of my equation equal the right side. Now, I would have to reject 20 if it were one of the numbers on my list of restricted values. But since 20 wasn't on this list of restricted values, I can accept it as a solution.